All right, hopefully in this short little video we'll improve your understanding of motion. In particular, my goal right now is to be able to describe and explain, help you understand motion graphs. Motion is simply a change in position over time. So we can have accelerated motion, where an object is gaining more and more distance each second that it moves. And this pertains to height, vertical position, horizontal position. Any of those changes of position over time describes motion. So we can have accelerated motion, where we're gaining more position, gaining more, or changing more distance per second. We can have decelerated motion, where an object is slowing down, where for every second that an object travels, we're gaining less and less distance, or its change of position is less and less. Or we can have unchanged motion, where an object at rest isn't in motion. You know, an object sitting on a table is not going anywhere. That's constant motion. Its speed is unchanging. Its speed is zero. Or you can have constant motion where the speed isn't changing. So we want to be able to understand and make predictions about motion using motion graphs. So here I have two sets of data, fictitious data here. So here's column A, data table A. We're looking at distance, and let's just go in terms of meters. We have 0, 1, 2, 3, 4, 5. So we're looking at the change in position of an object across 5 meters. The first column of time, think of them as splits, how the motion is changing each foot that it travels. And here we have a running total. And notice we're starting from motionless, starting from rest. And it took 0.5 seconds to travel the first meter. But if you were to compare that to the next meter took a whole second compared to the first one. The next one was even longer, and the next one was even longer. So between position 3 and 4, the object took 2 seconds, whereas in the first meter, it only took 0.5 seconds. So what's happening here? Each successive meter that it travels is taking longer and longer to travel. What does that look like in a graphical portrayal? It's this top one. So this top distance time graph goes with A, data table A. Because look what's happening here. We have a little bit of accelerated motion, but notice over time I'm not gaining as much distance. Each additional foot, like this first foot right here, took 0.5 seconds. But the next one, from 1 to 2, comparing to this time to this one, it took a whole second. And from 2 to 3, it took 1.5 seconds. So what's going on is it's slowing down. Eventually, if it flatlines, that means the object has come to a rest. Okay, so that's decelerated motion, looking at a distance time graph. Again, I could substitute height here, looking at the change in a vertical position. But let's look at data table B. If A was decelerated motion, we're anticipating B being accelerated motion. Well, let's take a look. We're starting from rest again. To travel 1 meter took 1 second, but look at the next meter, it only took a half a second. The following meter is a quarter of a second. So each meter is taking less and less time. And again, this is my running total. What does that graph look like? We're curving upward now. So for each second that the object travels, I'm gaining more and more distance. So this represents accelerated motion. All right? If you were to take the same motion and look at velocity time graphs, here's what you would see. So in the first one, data set A, well, we have decelerated motion. My velocity, v, or speed, is going down over time. And again, if this reaches 0, you could say at 10 seconds, the object came to rest, if this was velocity 0. All right? For data set B, for an accelerated motion, what do we have? This black line here, over time, my speed is increasing. So if this started down here, At time 0, I had a speed of 0. But over time, my speed is increasing. And constant speed would look like this. Over time, my speed is unchanging. So you can use graphs like this to explain and predict the ongoing motion of an object. So hopefully this little video tutorial gives you an idea of how to better understand motion in terms of the mathematical relationships we can see on graphs.